Hello all, my name is Shreya Chakraborty and I am one of the TAs for this course on Essentials of Data Science with R software. So we'll learn how to use R to make calculations easier and to get the essence of data science quickly via the use of this open source software. So every week we'll be having doubt clearing sessions. One will be on Saturdays from 3 p.m. to 5 p.m. and I will be taking those sessions. You will be able to learn or get a gist of what has been explained or what we have learned during the weekly lectures, and hands-on solutions or problems will be solved during these sessions. And it will be beneficial for you if you come to these sessions after looking at the weekly lectures, because due to constraint of time and also because of other reasons it might not be possible to repeat the entire course content during these sessions. Mostly I'll be focusing on the problem solving parts, and you have to it'll be better if you just have a look at the lectures and then come to these sessions. So today I'll start off right away. So in order to use this software, the first thing that we need is to download the software and install it in your system. So in order to download that, all you need to do is go to this web page rproject.org, and from here you can click on this download R option. Then you can choose the mirror of your preference. There is no such rule that you have to choose mirrors which are close to your area or your country of residence. You can choose any of these mirrors, and then the steps are very easy to follow. Just you have to select your OS, the operating system that you're working on, and if you just click on one of these mirrors, then R will be automatically downloaded into your system, and then with the regular installation procedures you will be able to install R. So after you install R, you would have some software which looks like this. This is how the R console would look like, and here you can make calculations like if I want to give 4 plus 6, 10 and all sorts of things. So this area is called the R console. Now instead of using R, I will be using R Studio, which gives a more user friendly interface, and every component of our analysis, like if we want to visualization, then what is there in memory, if we want to look at everything at one glance, I believe and I prefer R Studio because it is more user friendly. So in order to use R Studio, what you have to do, you have to open this link. I'll just post it in the presentation. So from here you can download R Studio. It should work. Okay, you can use this to download R Studio, and in order to download R, you can go to this rproject.org and download R readily. Alright, I'll provide these links in the presentation, which will be shared with you. Alright, so once we have our studio, if we go to this download section over here, then we can download our studio. So in order to use RStudio, first you need to install R, and the version of R that you are installing should be greater than 3.3. In the R console, right after you launch it, the version will be visible over here. And when it was released, like this version 4.1.3 that I have in my system, it was released in 2022. But if you want a more latest version, please feel free to download the latest version and then install RStudio for your OS. And the installation procedure, as I said, is fairly simple. And once you have the RStudio, it will look like this. Okay, so here in RStudio you have 4 panes or 4 panels as such. This one is similar to the console, R console that I was showing you. This area is for writing your scripts. This is the environment. Here you would have a history of all the commands that you have run, and this area will help you with the file location, folder locations, plots, packages, help button, viewer, presentation, and so on and so forth. So after you have successfully installed and opened R, you can use this software for a number of operations or calculations. So I'll begin to demonstrate what calculations and how you can go about using this RStudio. So for today's agenda, we have how to use RStudio as a calculator. So let's say you want to calculate something. So the first thing that you can do is you can directly jump onto the console and then write your calculations here. For example, if I want to add up two numbers, 777 plus 89302. Now when I'm typing in console, if I just press enter, I'm going to get the results. Alright, let's say I want to subtract 64 minus 7. Let's say I want to multiply 89.23, or I want to divide. Let's say any calculation that I want to perform, I can do it directly on an R console. But the thing is, it is very important to keep a log or track of the codes that we are using. These are simple calculations, but let's say we have a bigger goal in mind and we have to execute step 1, step 2, step 3 up to step n sequentially. Alright, so now if there is some error in my code, then if I don't keep a log of it, then what will happen is that I might have to redo all the commands, and that will take time. And also it is very important to save our codes for the purpose of reproduction or for any general purpose. So for that reason we have R scripts. So in order to open an R script, what we have to do is we have to go to this file section over here. Is it visible? I think now it will be visible. So all we have to do is we have to go to the file option over here, select new file, and then we have to click on R script. So this untitled one will be the name of your new R script. So what you have to do is you have to save this in your preferred location. I have saved let's say week1 underscore demo. This is the name of my script. It's an empty script, so I'll just replace it. Alright, so this is my saved script. Now I'll be showing, instead of doing all calculations over here, I will write this over here. Let's say I want to multiply 5 into 6. Now in order to execute this line, we have to press on run. So it is running. Again, let's say I have 68 into 67. If I click on run, then I'll have the output over here. This instruction will get copied on in the R console, and then it will get executed. Now you see here all the lines here will bear a certain line number, and if we just move a cursor to a specific line and then click on run, that command that specific line will be executed. Now instead of using this run command, the other way to execute a certain line is by pressing Ctrl and enter, or command and return or enter will execute the lines. For example, if I want to divide 7 by 9, I could click on run, but instead of that I'm going to press Ctrl and enter. So I'm getting this answer readily. Now if I want to execute all 3 lines together, then I will have to select all, or do a Ctrl A or Command A, and then after selection we have to click on Ctrl enter or Command enter. Then all of these will get executed at once. Alright, so let me start writing a formal script. Now a very important thing to keep in mind before writing script is that you have to ensure that your script has enough comments. What is the use of these comments? So suppose you are having a script, you are running a program, and then you have to give your code to someone else or for some downstream processing. Now the person that you're handing over the codes to might not be able to understand what is happening, by taking a glance at it, okay, at the first glance. So you have to supplement your code with comments so that any other person who's reading your code can understand what is going on very easily. Okay, so the way to do is that you have to add hash. Once anything that begins with a hash sign will not get executed by R. So this is like an instruction to R that if you see something that starts with hash, do not execute that line. Okay, if I use this thing, I don't think 7 is assigned to x. Alright, so I'll formally begin this. So the first topic that I am discussing currently is using R as a calculator. So I can perform addition, okay, control enter. I could perform subtraction, okay, multiplication, okay, and division. Okay, if I want to perform the modulo operation, let's say, what is the modulo operation? It is the remainder in a division. For example, 5 modulo 3 would give me 2. Okay, this is the modulo operator. Double percentage sign. Alright, okay. Next, we can also have a power or exponent. Let's say if I want 2 to the power 3, so we can use either this caret sign. This will also give this is one way to get something x to the power y. X to the power y. Here we have 2 to the power 3 or 2 cube. Or instead of using the caret sign that we have, that is this one, we can use double star. That would also indicate that this is something raised to the power 3. This will also give us 8. Okay, so we have the addition, subtraction, multiplication, division, modulo, power, some basic operations. Now, one thing to note is that here, in case of R, BODMAS rule is followed. Okay, so let's say I have 5 plus 7 divided by 8 minus 4 to the power 3 plus 2 into 1 or 3 into 3. Let's say this is my expression. So as per the BODMAS rule, we'll have these executed first. Okay, 4 cube, 7 by 8, 2 cube. So this will be executed as 5 plus 7 by 8 minus 4 cube plus 2, 3. We'll see that. This is minus 50.125. This is also minus 50.125. Now suppose you want to change this and you want -4 whole cube. The same thing you want, let's say this one. Then you have to specifically put minus over here, or you have to, so this will be, as I was saying, equivalent to -4 whole cube. Alright. Okay. So once we have learned the basic operations in that we can perform in an RStudio, let us move on to the use of some functions. Okay. Before using functions, let us understand how we can assign values to a variable. Okay. So let's say I have a variable x which will contain the value 6. So to do that, there are two ways. Either we can use the equal to operator sign, or we can use this sign. This implies the directionality that 6 is stored into R. Both of them will give us the same results. Now once we store values or data structures into some variable, we will be able to see that variable in the environment panel in this section of the RStudio window. Okay, so here I have x is a scalar quantity which holds the value 6. Okay, so if I write capital X equal to 8, then this value of x will not get overwritten because R is case sensitive. So we'll have two values of, we have two variables now. One is the x in lowercase, which has the value 8, and one in uppercase, which has the value 8. Okay, so this thing we should be very mindful of when we are writing our own programs, because R is very case sensitive, and if you by chance happen to put the same variable name, errors in case determination might lead to an erroneous code. Okay, so be very careful about the case that you are using, or whether it is uppercase or lowercase or sentence case, whatever it is. Like if I have arg equal to 9 and arg equal to 56.7, and both the data types are different. Okay, but instead of using this in subsequent code, if I use this, the entire calculation will be wrong. So we should be very careful in putting the names of the variables, or in the nomenclature of the variables. We should bear this in mind that R is case sensitive. Alright, so once we have learned about assignment operator, another thing is that there could be n number of spaces between the variable and the value. So if I write like this, x space 7, then also the value of 7 will get assigned to x. Alright, so this is how the assignment operator works. Now, up next we'll see some functions that we can use. So let us find out some mathematical functions that are super useful in performing any kind of analysis. Hello? Am I audible and is the screen visible to you? Alright, so we were just discussing about a few mathematical functions and how we should use them. So the first mathematical function that I want to use is, let's say, square root. So in order to find out square root of a number, there are two ways to do that. We can give this to the power 0.5, or we could make use of this function sqrt 25. Okay. Alright. Alright. The next function that we can use is, let's say we want to calculate minimum of a set of numbers. Okay, so we can type minimum, then the set we have to supply in this manner. Within this we have to write C, and within the C curly braces we have to give that set. So let's say 56, 89, 23, 7, 10. So if I press command enter or control enter, we would get the minimum of the set of numbers. Now what is this C thing that I have written? This is essentially a 1D array, or in terms of our data structures we call it as a vector. Yes, any issues? Okay, fine. So this is called a vector. Vector is essentially a 1D array, and this one we can assign, let's say I want to assign this vector to a certain variable. Let's say this is my vector. This is the name of my vector. So I could use this equal to sign, or I could use this operator. Alright, I'm using this one. So once I do this, in the environment section we'll see a my vector variable, which is of type numeric, and it has 5 elements. 1, 2, 3, 4, 5. If it is a very complicated data structure, in order to view what actually the data structure is, we can use this command str, and str my vector would tell me, would give me this exact information, that it is a numeric vector of length 5 and these are the elements. Alright. Now, next thing that we want to learn about is the index of this array. So, I have 5 elements in this array. Now, let's say I want to subset the first 2 elements. So, in order to subset, we have to keep in mind that vector indices start from 1. So, it's very straightforward. It's unlike some other programming languages where the indices start from 0. What I mean is that in order to access the first element, I have to write, to specify the name of my variable. Within third braces, I have to specify the index that I want. So if I want the first variable, that is 56, I am going to write my vector 1. This gives me 56. If I want the first 2, then I am going to write, then if I write 1 comma 2, this will throw me an error, because this particular format indicates that this vector is not a vector but it is a 2D matrix. So we have to use this C command, and then we'll get the first 2 elements. Alright, if I want to get the last 2 elements, or let's say I want the vector without the second element. So if I want to subset the vector such that the second element is not present. So there are 2 ways to do that. One is I give my vector, write 1, 3, 4, 5, then the second element will be removed, or I could give my vector -2. If I don't want the second and fourth element, then again I have to write my vector, or the name of, then within C I have to write 2 and 4, and before C I have to give a minus sign. So then the second element and the fourth element will not be reported. Alright, now this is how we subset a vector. Now why did we start learning about vectors? Because there are some functions which would take a vector as an argument and then report either the minimum or the maximum. Alright, so as I was demonstrating, let me find out minimum of my vector. So I can give minimum of my vector. So it is throwing me the minimum. If I want maximum, then I have to write max my vector. If I want, let's say, the median, then I can write median my vector. So I hope you are familiar with the concept of median. Median is that value of x which will divide the entire data set into 2 halves, the middle value. So in order to determine the median, what we had to do is that we have to arrange it in ascending or descending order. So I'll write it here. Let's say I have let's say I have here, what do we have? Here we have 56, 89, 23, 7, 10. So first thing is we have to write it in ascending order. So that is 7, 10, 23, 56, 89. Then step 2 is we have to find out total number of n is odd or even. Here n is 5, that is odd. Then median will be n plus 1 by 2th observation. That is, in this case, third observation. Which is the third observation? This one, 23. And that is what has been reported over here. Median my vector is 23. Okay. If in case we have 6 elements, I'll now add one more element to my vector. Let's say my vector 2 equal to, if I want to add more number of elements, I could do one thing. I could copy from here and add the required number of, let's say, elements here. I had these, I'm going to add 42. This is one way. We have to be very careful about brackets, because any bracket that we open has to be closed, otherwise we'll get such errors. So see, my vector 2 now has another element. Now one more way that we can do that is my vector 2 equal to C of my vector comma and the element that we want to add, let's say 43, 44. So now you see this my vector 2 change that 42 to 44. Alright, so these are two ways by which we can augment to a vector. We have to keep in mind that the order that we are using, that has to be compatible. What I mean to say is that if I do my vector 3 and if I give C 44 and my vector, then the indices will change. So the first element of my vector 2 is 56, but of my vector 3, because we have reversed the order, the first element will be 44. Alright. Fine. So as I was saying, now this my vector 2 has 6 elements. So if we have 6 elements, we had these 56, 89, 23, 7, 10 and now 44. So again we'll rearrange in increasing order: 7, 10, 23, 44, 56, 89. Now here n is how much? N is 1, 2, 3, 4, 5, 6. 6, that is even. So then median will be n by 2th observation plus n by 2 plus 1th observation divided by 2. So that will be 3rd observation plus 4th observation divided by 2. So it will be this plus this by 2, which is 7, 67 by 2, it will be 32. 33.5. So now if we take median of my vector 2, we would get 33.5. Alright. Okay. So we have considered mean, median, maximum. Let us find out the absolute function. So absolute function is nothing but the mod function. If you find something like this, let's say mod x or mod 5, mod minus 5. So all this would also yield 5, this would also yield 5. We need the absolute value. So in order to get that, here the command is abs, and we can specify only one argument. So absolute minus 5.5 will give me 5.5. Now another function that we want to look at is, let's say, round. Round will do what? It will round up or down to the nearest integer. Let's say I have round 78.48, and I want to digits I'll specify as 1. So what does that mean? It means that it will be rounded up to first decimal place. Okay, by default this will be rounded up to an integer. So the default, if I give round 78.48, we would get 78. Here this digits parameter would be equal to 0. But if I specify digits equal to 1, it will be rounded up to the first decimal place. Now 78.48, when we are using this, it is rounded up to 78. But when we are using this, it is rounded for this, since 8 is greater than 5, it is rounded up. Similarly, if we give round, let's say 78.58, then it will be rounded up to 79. Alright, let us see what happens if we give 0.5. 0.5 will also get rounded up. Okay, now let us we always round up, or we don't want the computer to decide for us. Let's say we always want the base or floor or seal. So we'll see how we can use this. Let's say we have seal. Seal will always round up. Seal of 78.48 would be, oh, it couldn't find seal. Okay, floor, let's find out. Floor will always round down. So this one will become 78. Okay. Alright, could not find function seal. So I'll just see if this exists or not. Seal function in R. Okay, it exists, but might be in different with a ceiling function. Hmm. Okay, ceiling 78.48 will round up. Alright, so then we have covered these sum and product. Okay, let's say I want to add up the number of elements that are present in my vector. Okay, now I could do one thing. I could manually write 56 plus 89 plus 23 plus 7 plus 10. The sum is 185. Or I could write here within sum C of 56, 89, 23, 7, 10. This essentially is nothing but my vector. So we can write sum of my vector. So sum of any vector would give you sum of the elements of that vector. Alright. Similarly, if I want product, let's say I am taking another vector. I am going to assign 1, 4, 7, 9. Okay. Now prod of A would give me product of the individual elements. Alright. So sum, products we have covered. Now let's say I have, okay, now if I want to find out the logarithm, so if I give log 10, by default it will take base as e. Okay, or we could also use ln. Okay, no, ln doesn't work. Log 10 is nothing but log to the base e. This is, okay. Now if I want something to the power, if I want log 10, then I have to write log 10. If I want log base 2, I have to give if I want log base 3, okay, then I have to give log 9 base 2, 3. Okay, so log 10, log 2 and log, these exist, but if we want the base to be something else, or even if we want them to be these, we can just specify using the base parameter. Now suppose, how will I know whether which function is taking which argument? For that I would need the help section So one thing is that in R, once you type, let's say I'm typing prod, or if I just give log itself and press tab, then a prompt like this will come up, which will tell us what arguments this function is expecting. Now even then, if we are not so sure, we can always invoke the help function. So to get that help function, we can click on help over here and look at the manuals. Alright, here we have the introduction, how to import, export, what sort of packages are there, and so on and so forth. We can invoke the help function using the F1 command. So what I did was that I took my cursor here and I pressed F1. Then this help our documentation opens up. Here we would find what the function is doing. Okay, some usages, how we can use these, and the arguments, some details, the source and the references, and also most importantly the package information. So within the curly braces, whatever information you find in the documentation page, that is the package where this command is I would say compiled, or where it has been loaded. Okay, so sometimes it is very possible that you might be interested in using a function which is not preloaded with your R. By default, RStudio or R will have this base package installed within your system. But sometimes you might be interested in using something else which is not present in your system. So then you might have to fetch them or install those packages prior to using them. So let's say I look at these packages and I'll go to the help section. Then let's say I want some let's say here I want this package or some other package. Let's say install. So in order to install packages, what we have to do is we can go to the here and we have to write install.packages. Within double quotes, we have to specify the name of our package. Let us say I want dplyr. This is the package that I want. Okay, so updated or currently loaded. So they are asking me to restart. I'll restart the system. So in RStudio, one of the advantage is that even if you forget to save it, it is not completely lost. But for just for the sake of safe coding or coding practices, we'll ensure that everything is saved. Okay, now here since this is already installed in my system, I was not able to do this. So if we go to packages, all of these packages are pre-installed in my system, but the ones that have these tick marks only those are loaded in the environment. Alright, so if I want to use, let's say, ggplot, okay, could not find function ggplot, but if I load it in memory, it will be able to recognize library. Let's say if I write ggplot2, and then if I write ggplot something, if I want to give, let's say, my vector only, then it is showing me some error because it's not a compatible format, but the function is running. So all I want to demonstrate is that even if you have some package preloaded in your system, you have to, even if it is installed, you have to load it using this library command. Alright, so this was all about packages. Now let us learn how to make plots. So let's say I have this vector x equal to something 6, 7.4, 8.9, 1, 10, 3, 27, 97, 68, something 35.5. Now I can, if I want to make a, let's say, histogram of this, the command is to write hist x. So here it's not giving me a proper result, but a histogram will give us the frequency in this section and the values of x in this section. So I'll just increase 4, something like this. Okay, so let's say I want a box plot, then the command is box plot x. Okay, so this entire thing is a box plot. We'll learn more about this. These values are called outliers, and this gives the 5-point summary. This line that we find shaded in dark, that is the value of the median. Okay, so any plot that we want to make will appear in this plots section here. Now if we want to copy or extract it, all we have to do is we can export it, we can save it as an image, we can specify the formats. It could be a PNG, JPEG, TIFF, PMP, and these. We can specify the directory where we want to save it, the name of the file, and if we want to change the dimensions, then also we can do it. Let's say 600, 335, something like this, or we want to increase. Okay, and then we can save it as a PDF or image file. You can also save it as PDF and make changes here to the dimensions, or we can also copy this to keyboard, make changes, copy plot, and then if we have somewhere where we can paste it, we can just go ahead and do that. Okay, so this is how you can export or take, copy or save graphs that you uh, get as an output from your analysis. So if I want to draw a scatter plot, so what does a scatter plot essentially look like? It is a bivariate plot with x on y axis. So this one was a box plot. So if I want a scatter plot would look like this. Here you would have x values, here you would have y values, and there will be dots scattered like this all over the place. Okay, these are not lines but dots. Okay, this is dots, something like this. Okay, so in order to do this we need two variables, x and y. So let's say I have x equal to, I'll put some random numbers, 3, 3.5, 5.2, 2.3, 7.8, 4.5, 7.4, 2.1, 3.5, and so something I'll put 3.6. okay, and corresponding we'll put some y values, 10 y values. How will I determine how many number of elements are there in x? It will come here once we run it. So it has 11 elements now. Or the other way to look at it is using the length function. Length of x will give us how many elements are present in this vector. Alright, so now we need 11 y values. So 4, 4.5, 7.1, 2.3, 4.6, 7.8, 9.2, 4, 5, 19, 2, 11. So I think the y vector also has, now in order to check, I'll just check the length of y. Oh, it has 14 elements. Oh, then I have to remove some. Okay, it has 10 elements. Okay, so I'll just remove one from here. Okay, so now x also has 10 elements, y also has 10 elements. If we just give plot of x and y, we get this kind of a scatter plot. Okay, if we give plot xy type equal to L, then all of these plots will be joined by a line. Okay, if we give plot xy type equal to H, we will get a plot like this, where y, for each of these points we will have this column chart. If we give plot xy type equal to S, then we will get steps. So if you see something like this, where it looks flat and then looks like steps, you should be able to understand and determine what type should be used to get graphs like this. think the connection has dropped. All right. So, as I was explaining, if you have plots like these, then you should be able to identify what has gone wrong. All right. So, up next, we'll see how to use logical operators. All right. Hello. Are you able to see now? I'm really sorry the connection dropped. Is the screen and the R console visible? Okay, thank you so much. Yeah. So, till which point were you able to follow? I'll re explain. Till seal. Okay. Oh, okay. All right, all right. Okay, okay. All right. So, we learned how, till this part it's clear, right? Seal will round up and floor will bring it down. Next I was explaining how we can use the sum command. So if I want to add up the elements of my vector, this vector, all right, so one way to do that is I'll put a plus sign, I'll write the elements individually and put a plus sign in between. So that will give me this thing. Or I could supply the entire vector to that sum command, and then that will give me the sum of individual elements of that vector. Okay. Okay. All right. So sum of these. Now similarly, if we want the product, let us say I have this vector 1479. If I give prod A, I will get 1 into 4 into 7 into 9. Okay. Now next, if I want the logarithm. Okay. So for that, we can, if we give log and just specify the number that we want our logarithm, then by default R will assume that the base is E. Now if we want the base to be something different than E, either we can use this, we can specify log of the number that we want the logarithm of, base equal to 3, let's say. So either we could do that for all the bases, but R by default has log 10 and log 2 also, where the base is the base of the logarithm is 10 and 2 respectively. Okay, if I want to write log 4, then I'm going to get errors because it couldn't find log 4. But if I want log 4, I will have to do log of something, let's say 16, base equal to 4. Okay. Now the next thing that I was explaining is that, let us say I am not aware of this function and the parameters that it could take. So what can I do? I can move my cursor to this function and just press I press F1 command. So once I press F1, you will see this documentation opening up on the right side. Okay. This one, the first thing that comes is that log function is a constituent of which package? It is a constituent of the base package. Now base package is by default installed into your system when you download RStudio. Okay. Now here you would find the description, what this function is doing, how to use that. Okay, some example usages, what the arguments are, what is the function expecting. So it is expecting a numeric or complex vector, a positive or complex number, the base with respect to which logarithms are computed, defaults to E, that is exponential 1. Okay, and the methods that they have used, the sources and those kind of things. Okay, everything here, and some example usages also. Now I was talking about packages. So some packages are already installed in your system. For example, if you want to take a look at which packages are already there in your system, all you have to do is click on the packages section. Okay, so few of these packages are already there in your system. But if you want to update or if you want to install something, okay, let's say I want to install some R package which I do not have. Let me find out. Let's say this one. I want to install XML package. I'll just see if I have it. Oh, I do have it. Okay, so some package. Okay, let me install this tidyverse. Okay, so if I want to install this package, even though I have it, but still I'll do that again. So if I click here, see, I have done a mistake, and that is why it is showing a cross sign over here, and we have a plus sign over here. Once we have this, this indicates that it is expecting something more. Now the mistake that I did was I have opened this quotation marks, but I have not closed it. So it will never be able to find out. Now if I give this also in the console, it is expecting more. So then what I have to do, I have to press Ctrl C in order to get this greater than sign again. Okay, and I'll just rewrite install.packages tidyverse within quotes. Any package that you want to load or install, sorry, not load, install, you have to specify that within quotes. Now if I run it, it is, see, it's running. Trying URL. And the package is downloading, and it is downloaded and saved in this folder. Okay, so if I want to see what all functions are there in this tidyverse package, I will go to this tidyverse package and I'll click here. Okay, so here I have user guides, conflicts, packages, update, something, description file. Okay, user guides, something. So some functions you can explore this and find out. Okay, tidy tools, there should be some function. I'll just find out. Okay, so if I want to use this library, this package, I would have to load the, so here there's one command which comes from the tidyverse package. It is called arrange. No, sorry, tidyverse R. So this has a data set that is called empty cars. Okay, so if I just give print empty cars, oh, it is getting loaded, maybe because it's already installed in my system. No, it's there in data sets, sorry. Okay, so the main point is that only installation will not work. You have to load that library into your system to be able to use those packages. Mm, for example, I was giving this example of ggplot. Now, if I just remove the environment over here, whatever I have, I'll clear objects from workspace, everything is removed. Now, ggplot is not loaded in, oh no, it's, sorry, it's still not removed. In one session, it is not. Okay, so what I mean to say is that any package or any function that you intend to use will come from a package. Now that package could be the base package, could be something else. So in order to use functions which are embedded in some package, after installing, we'll have to load it into the environment, and for that we need to use the library command. Okay, in the subsequent sections or classes, we'll be able to learn more on this. Okay, sometimes also what happens is, after you click on install.packages tidyverse, or any the package name you give, R will throw a prompt which will ask you to supply the name of or number of the mirror that you're using to download it. Okay, so at that point you could either give the code of your country of residence or nearby countries, or you could give anything. The same package will be downloaded and installed in your system. Okay, next thing is that how if we want to make plots. So for example, let us have this vector, all right, and I want to plot a histogram. So to plot a histogram, the command is hist. Now once you click on, you can make edits to these functions, but plain and simple, by default it will give you the frequency column and the x column. It will come in the plots section. So if you want to save this image, you can just click on export, save it as an image, adjust the dimensions of these images, select the compatible or desired file format, image format, and then click on save. Okay, you could save it as an image, you could also save it as a PDF, where you can specify the dimensions if you want it in a portrait mode or a landscape mode, and the file path where you want to save it, and the name of your file. Preview option is also there if you want to preview. This is what your diagram would look like. Then you can just go ahead and save it. Also, if you do not want to save it, you just want to copy and paste it, that option is also there. You just have to copy it to clipboard, adjust the dimensions, copy plot, and then come here, paste it, done. All right. Were you able to do it? Okay, fine. Now instead of histogram, let's say we want a box plot. So we'll learn more about box plots in subsequent classes, but these points are your outliers. If you have you ever heard of outliers? Uh, yes, a certain boundary is specified and points falling beyond that boundary region are outliers. So this gives this will give a glimpse of the minimum, maximum, the range of the values. This dark line specifies the median value. Okay, and these will be your quartiles. We'll learn about more about this thing. So you can also plot a histogram, a box plot, or any kind of one dimension visualization for a one dimensional vector using the R software. It will appear in this section. You could zoom in to have a better view of your plots. Okay, you can make changes, like you can add title using main equal to, let's say I'll write box plot. You could add footnotes by using sub equal to something. You could add labels, xlab, let's say x, ylab equal to frequency or something. Alright, so these are the standard arguments in any plot function. Okay, now if I want to plot a bivariate two variables together, I want a scatter plot. So what I want is that I'll share on a screen. I want this plot, x on the right, in the x-axis, and y here. So to do that, the R screen is visible, right? Okay, so here I have taken an x vector. It's a numeric vector with 10 elements. Now the length function, length of a vector, will give you the total number of elements present in that vector. Alright, so length x here, if I click, it is showing me that the length is 10. Similarly, I have taken a y vector, that length is also 10. Okay, now if I just write plot of xy, I am going to get a scatter plot. So this one is 2 5 combination, 2 5 point or 4 point something. Alright, these are the points and these are their corresponding x and y coordinates. Okay, now if I specify plot xy type equal to L, what is going to happen is that all these plots will be joined by a line. Okay, if I specify type equal to H, then I am going to get a plot like this. Okay, like a column chart. And if I specify type equal to S, it will give me something which will look like steps. Alright, okay, so once we have that, so if you are suppose given this diagram, let us say this is your question. you have something x and some y, and this is your command. Okay, you have written plot x y type equal to what. So what do you think this type should be? This is looking like steps. Okay, so then this type should be S. Okay, all right. Now what else do we have here? Okay, so we have covered these. Now we'll look into some logical operators. Now logical operators will give an output of either true or false. So let's say if I want to find out 4 less than 5, this is true. This is a logical operator. Sorry, this is a relational operator, not logical. So logical operators also give this true false output. Alright, so let's say I have this vector x. I want a subset of x where x is less than 5. Okay, so if I give x less than 5, see the first element is 3, it is less than 5, so we are getting true. The second element is 3.4 less than 5, we are getting it as true. Third element is 4, 5.2, it is exceeding 5, so this criteria is not satisfied. Alright, so then we are getting it as false. Okay, so if I want a subset of x where x is less than 5, all I have to do is x such that x less than 5. So it will give me all such values of x where x is less than 5. So x less than 5 is giving me output wherever it's giving me a logical output, whether it is true or whether it is false. Okay, x such that this thing within third bracket will give me only those positions where true value is returned. Now let's say I want something like this. I want to subset x whereas 5 less than x less than 7. So I could write this as x such that x less than 5 or greater than 5 and x less than 7. So this is my logical operator AND. We could write AND. We could also write double AND. This is the AND. So if both the conditions are satisfied, only then a true value will be returned. Okay, so if I give true and true, then only I'll get a true value. Anything other than that, at least one false also will give me a false value. Okay. Similarly, this is the AND command. If I want OR, then true or true will give me true. Only false or false would give me false. Okay, you could use one symbol, you could also use two. It's equivalent. Now back to this subset problem. If I have x such that x greater than 5 and x less than 7, this criteria will return only, so I'm selecting this smaller part and then I'm clicking on command enter. So I'll only get the positions where true values are present. So true is present only in one location. So this will give me that value where both the criteria are satisfied. Got it? Okay. So this was about subsetting. Also, anything else, if I want, let's say 4 less than 5 will give me true. 4 not equal to is exclamation and not equal to 4. Sorry. This will give me false. Okay. Greater than, less than, anything. Less than equal to, 7 greater than equal to 5. This will return true. So in order to make conditions like or extract values where we have to put such kind of conditions, like this should be greater than this one but this should not be equal to this thing. So then we have to use a combination of these relational and logical operators. Alright. Okay. So then the next thing is how we can draw samples. So there are two schemes. So we are focusing on simple random sampling. One is with replacement and one is without replacement. So let's say you have 10 balls over here. Okay, so you have 10 candies over here, let's say, and you are taking out 5. Okay, you are randomly selecting 5. Now usually by default, if I just give you this information, this is sampling without replacement, because once you have taken a candy, you won't put it back inside and then fetch another one. Alright, but let's say you are tossing a coin or rolling a die. Okay, so every time you are throwing this die, or let's say something you are taking out from that set and then you are replacing back. You have 10, you are selecting one, noting down the value, and then you are putting it back into your bag and then again picking up. So this thing is sampling with replacement. Alright, so by default, like I said, R will also conduct sampling without replacement. So let's say if I have this y vector, if I just put sample and I have put a tab, so here it will prompt the arguments that it is expecting. Okay, so x is the vector from where I am going to sample. So I am going to sample from y. Size is the number of size is actually my sample size, the number of elements I want to sample. So let's say I want to sample 5, as I was saying, and I write replace equal to true. So then I am getting this. Alright. Since this is a random sample, if I just rerun it, every time I run it, I am going to get a different sample. There are ways where we can fix this. I mean, we have to set some seed for doing that, but essentially this is sampling with replacement. If I just write this much, then by default this will be without replacement. Okay, so if I just run it, here you will see what is happening. Why is it not? Oh, okay. So here, even though the numbers are repeating, it is because we have repetitions in our whole set, but not the exact same thing is coming. So if in order to demonstrate, I need to show something else. So let's say I have a vector j where I have 4, 2, 3, 6, 91, 37, 29, 14. Okay, so if I sample from j with replacement, there will be repetitions, like here you see 6, 6, 91, 2, 91. But if I do not use this replace equal to true, by default it will, no two elements will be the same. Okay, here we are doing sample y, sample j. So here no repetitions. Okay, now here I am sampling from a particular vector. Let's say I want a vector. My question is I want to sample from first 100 integers or first 100 natural numbers. Okay, so I could do one thing. I could just write, give some variable name var equal to, I could write c1, 2, 3, 4, 5, 6, so on, so on. But this is tedious. So what I can do is I can write var equal to c or c1 colon 100. Okay, so what this c1 colon 100 is doing, it will list the numbers from the first number to the last number and increment it by 1. Now if I want something like this, I want the numbers all even numbers. I want all even numbers between 1 to 100. So what should I do? I can use this seek command. This will generate a sequence. Start will be 2, end will be 100, by equal to 2. So here you see the length of, so if I just assign var 2 equal to this one, length of var 2 will be 50. 50 even numbers between 1 and 100. Okay, and from the console itself, if we want to know that 62 is which element, okay, so one thing to do is 46 is the 23rd element. Okay, so the numbers within these square brackets indicate the index positions of the immediate right variable or element. So if this is 23, 24, 25, 26, 27, 28, 29, 30, 31. Okay, or in order to find out, I can also use this command, which x or var2 equal to 56. That will give me that 28. This was 26, 23, 24, 25, 26, 27, 28. Okay, this which command and this equal to operator. So I forgot to ask about this operator. I mean talk about this operator. So if there is one x equal to 2, let us say I have a variable k. Okay, I assign the value 5 to k. Okay, but if I write k equal to 5, then it will give me, I mean it will output whether this statement is true or not. Alright, so one single equal to will assign, double equal to will give you the logical output whether k is actually equal to 5. If k is equal to 5, if it is yes, then it will output true. If it is not, it will output false. Okay, now this was about sequence. Now let's say I want an array where it will be 1 3 1 3 1 3 repeated 10 times. Okay, so for this we can use the rep command. Replicate, see the vector that I want to replicate is 1 3 and the number of times is 10. So if I run this, I will get 1 3 1 3 1 3 1 3 and so on and so forth. Now if I want 1 3 times and 3 5 times, so we can write replicate c1 3 comma c3 5. Okay, this will replicate the first one thrice, the second one 5 times. Now if I want this 1 3, if I specify each equal to 4, then I'll get 1 1 1 1 3 3 3 3. Okay, and then this is how you replicate. Now I want to do some addition or numerical operators on vectors. So I have this j vector. I want each element of j to be multiplied by 2. So all I have to do is 2 into j. Okay. If I want that every element of j should be divided by 3, so I'll write j by 3. Similarly, my addition, subtraction, modulo, square root. If I just give square root of j, it will give me square root of the individual elements. If I write j to the power 2, then it will give me square of each of these individual elements. Now let's say I have a vector C389 and I want to multiply this with C123. This is not dot product. This is not 3 into 1 plus 8 into 9, 9 into 3. That is something else. Okay, that operation will not be carried out if we just give the star command. So this star command will do individual element wise operation. So if I do this, then what will happen? 3 will get multiplied with 1, 8 will get multiplied with 2, 9 will get multiplied with 3. Okay. If let's say the lengths, there is a length mismatch. So let's say I have a vector, let's say I have a j vector where there are 8 elements. Into I do 2 and 3. So what will happen? 4 will get multiplied by 2, 2 will get multiplied by 3, again 3 will get multiplied by 2, and so on and so forth. Okay, but it will not generate any warning or any error. This thing will go about in a round robin fashion. Okay, so if I have m, let's say another simple example, if I want to give 4, 5, 7, 8. Okay, that into C23 will be, so m will be 8 into 2, 4 into 2, 8, 5 into 3, 15, 7 into 2, 8, 14, 8 into 3, 24. Now if I write like this, m is 4, 5, 7, 8 into 2, 3, 5. Then what will happen? This warning message will be generated that longer object length is not a multiple of shorter object length, but you would get some result. What would the result be? Result would be 4 into 2, 5 into 3, 7 into 5, then again 8 into 2. This pattern will continue. Same thing will happen if you just if you use multiplication, addition, whatever, plus if you do, it will throw a warning, but it will go about in a round robin fashion. So while working on R, it is very important that you do not ignore the warning messages, because there could be something lurking around here that could give rise to potential errors in your code. So never ignore warning messages. Try to remove or get rid of those by coding correctly while you still get your own uh, task done. Okay, now I think we have covered almost everything in our agenda today. Now if, let's say, I want to remove some variables loaded in memory, I could use the rm. Suppose I don't want this k variable to be remembered by r. I could use this command rmk, and then you'll see k is gone from here. If I just want to print k, it will show me object k not found. Or another way is you go here and then you clear the entire environment, or you just specify the list of elements that you want to clear. Suppose I want to remove var2 and x. So I put it in a comma separated list and it will vanish from R's memory. Alright. So this is one practice sheet that I thought I would discuss today. In order to start the practice session, or in order to start any help section, the command you need is help.start. So once you click on help.start, you will get this help. The other shortcut was F1. And if you have a function in your mind and you want to know how that function looks like, what output it gives, then you have to use this example command. So there is a popular function lm which runs linear regression. So if I just give I'll clear it out. First of all, I'll clear the environment, I'll clear my console. I could either use this brush or I could use Control L. Control L will also get rid of this area. Okay, so let's say I want to run this example lm. So I run it. So this is an example. It requires graphics. Okay, so some CTL is a variable where these values are assigned. TRT is another variable. Control and treatment, another variable is assigned. There's a group variable. Okay, some weight variable, lm on weight upon group, no test. This is the ANOVA results that we have. This is the summary. These are the coefficients, and this is the end of test. Okay, so if you want to run an LM test, probably these are the possible steps that you need to do. Now these will be tweaked based on your goals and your analysis, but this is what a typical LM function would return. Summary LM would return this part, and ANOVA LM would return this part. Okay, we will learn more about how to interpret these things, but this is how you should start. Also, if I want an example of a plot, so LM plot would look something like this. Okay, if I want an example QQ norm, so it will look like this. Okay, all right, are you there? Okay, now these are some practice questions. Let's say x is 35, y is x to the power 4, z is y minus x whole cube. So what will be the value of this thing? Okay, so first thing that R will do is 35 cube and then subtract it from x to the power 4. Okay, this and this are equivalent. Also, if I have x equal to 9, y equal to 2, if I want the square root of absolute difference between x's cube and x's 4, and then I want z equal to x minus 5. What would be the resultant value? You could also have expressions like this, where you have to evaluate using the Bodmer's rule and the rule that R follows in their order of precedence, and then get the values out of it. Okay, here again we have some, so I am going to solve this one so that we know what the output is coming. All right. So here we have this. Can you see my screen? Please reply. Yes. Okay. So here what we have here, there are 4 elements, will be divided by 4 elements into something to the power something plus 3 into this. So if I focus on this part, this will give me C of 3 into 121, 211 into 13, and so on. Okay. This raised to the power this part is what? It will be minus 2 to the power 3, minus 9 to the power 2, 3 cube, 2 square. Okay. This part would yield this one. And this part would be C of 12 by 12, 18 by 8, minus 32 by 7, minus 15 by 6. Okay. Then we have to do is this one and multiply into this one, element wise multiplication. Okay. And then whatever this resultant will get, that minus this vector will give us the final result. Okay. So in your exams, what is going to happen is that you'll be provided with code snippets, and you might be asked to report what the value is or how to do that. So if you, most likely you won't have access to your R softwares during your exams. So then these concepts should be very clear to you so that you can answer in pen and paper what R is actually reporting. Alright. Similar question is this thing, square root of this one to the power C24. So here you see, okay, again here, this is this one, sorry, where is it? Oh no, my pen is not working. Okay, so this part, so first thing is this one, evaluating this one. So C minus 12 minus 13 minus 15 5 to the power C24 means minus 12 whole square minus 13 to the power 4 minus 15 whole square 7 to the power 4. Whatever we'll get, that into again this thing to the power this thing, 22 to the power 22 square, 23 cube, 24 square, 25 cube, minus this one by this one means 8 by 12 by 8, 10 by 3, again 16 by 8, 18 by 3, and then minus of 16 cube. So these all calculations you have to do and you have to report your in your assignments. All right. Okay. So another question, this is also another similar question with summation, minimum, product, square root. Okay. Alright, this is another relational operation thing that I was showing you. Let's say x is this. I want x such that x greater than 50. Or I want x such that x greater than 50 and x less than 90. Something like this. I could also want something like this. X such that x square minus 6x is greater than 300. So wherever this is satisfied, those elements will be thrown to me. Okay. Alright. So we could also get questions like this. Which of the following is a possible outcome of the command? Sample x, size is 6, replace is false, where x is sequence 10, 40 by 3. So x will have the values 10, 13, 16, 18, 21, 24, 27. Am I correct? 10, 13, 16, 19. No. 22. Here we have 25, 28, 31, 34, 37, 40. So this is the X set. I am doing a sampling of size 6. So first things I have to see whether I have 6 elements or not. So all of the options have 6 elements. Now replacement is false, which means that no 2 elements should be repeated. So here we see that in none of the answers any element is repeated. So this holds true. Then what do I have to do? Sequence 10 to 40. So the values should be coming from these ranges. Okay. So here if we see something which doesn't confirm, let's say this one, option B, because 23 is not in that set. So option B is the correct answer. Is it okay? Similarly, let's say this one. Which one do you think is not a possible outcome of the command? Sequence 10, 30 by 5. So it will be 10, 15, 20 and so on. Okay, so it will go from 10, 15, 20, 25, 30. So which of the following is not a possible outcome? All of these are multiples of 5. No doubt about it. But here we are doing sampling without replacement. Sample X. So we'll see whether anything is repeated. Anything is repeated? Can you see? No. But then we have an element 22 over here, which is not a multiple of 5. So this is not a possible outcome of the command. Okay. Similarly over here, which of the following are possible or probable correct outcomes? So 10 to 30 ranges should be satisfied. Size is 5, so first option is out of question. We have more than 5 elements over here. Replace equal to 2. There could be repetitions, we need not bother. Minimum should be 10, maximum should be 30. So minimum 10, maximum 30 is satisfied here. And it also all of the elements fall in that 10, 30 by 3. So all of these are correct. Is it okay? Okay. I think the 30, yes. Yes. Alright, so I think we have come to the end of today's session. So from the next week, I'll discuss week 2 problems. And if you have further questions, please write it in the discussion forum. Every week, the class will be from 3 to 5. Please pardon me for the network interruption that happened today. And we'll be solving more problems and hopefully, yes. Yes, what is your question? Are you typing your question? What email to write question? Oh, okay. So in your, when you once you log in to your Swayam portal, here you will see there is a discussion forum. Not able to find it, I don't know why. One second. Here you have ask a question, this type. So if you click here, this will open up to a Google group page. So you could post questions about the sessions that are held, all right, and we'll be answering to your questions here. This is one way. The other way is you join in the next class with your questions and get it solved right there and then. I think the second option is more fruitful, because then even if you're not, sometimes it might happen you're asking something but the instructor or the course TAs are not able to provide uh, exact answers to your questions. So it's better to join the sessions, go through the lectures, then you come to the sessions, we'll solve some practice questions. If you have some doubts, you get it cleared, and then your learning will be a more smooth, it will be more smooth, and the experience will be probably helpful and beneficial. Okay, so thank you so much for joining, and write to you direct. I don't think direct channel will be encouraged, so you post it in the discussion forum and we'll answer your questions there. All right, okay, thank you so much for joining. Have a nice day. Bye bye.